Hello everyone, I welcome you all to this next video in the Spring Code lecture series. We have come towards the end of this lecture series and this video will be about Aspect-Oriented Programming or AOP for short. Before I begin, I would like to thank my subscribers and viewers. You people are the only motivation for me to continue to make these videos. I always think of you people putting in your time and efforts to watch my videos, and I always try to bring out the best content possible to you. Always keep watching, learning, and growing. With that, let us get started on this video. If you haven't already, please subscribe to the channel, like the content, and share the content as much as possible. Let us understand AOP conceptually. Up until now, whatever concepts we have learned are majorly from the perspective of beans or regular OOP paradigm style development. In this development scenario, we basically assume classes to be the carrier of functionalities within an application. For example, we have email sender and its default implementation to provide us email sending functionality. However, there is another set of functionalities which does not follow this regular OOP paradigm style development, and the most prominent example is logging functionality. Instead of building logging logic separately in each class, you would want something which automatically takes care of logging in an application. All such functionalities which don't follow the standard beans development model, that is, they cut across multiple class boundaries or even module boundaries, are what we call cross-cutting concerns. Aspect-oriented programming as a technique is modularization and implementation of these cross-cutting concerns. Let us understand the core concepts governing aspect-oriented programming. Aspect. An aspect is the cross-cutting functionality you are implementing. It is the aspect or area of an application you are modularizing. Join point. A join point is a point in the execution of the application where an aspect can be plugged in. This point could be a method being called, an exception being thrown, or a class field being modified. Do note, Spring AOP only supports the method being called join point. This also resonates with Spring philosophy that field interception violates encapsulation. Advice. Advice is the implementation of the aspect. Advice implements the action taken by an aspect at a particular join point. Point cut. A point cut defines at what join point advice should be applied. A target is the class that is being advised. Without AOP, this class has to contain its primary logic plus the logic for any cross-cutting concerns. With AOP, the target class is free to focus on its primary logic. Proxy. A proxy is the object created after applying advice to the target object. Proxy classes wrap the target object and intercept the normal method call execution to execute expects before the control flow is passed to the target again. As far as callers are concerned, the proxy object and the target object are the same. That is, the rest of the application will not have to change to support proxy classes and AOP. Weaving is the process of applying expects to a target object to create new proxied object. The weaving can take place at several points in the target class lifetime: compile time, load time, or runtime. Runtime is what Spring uses. This makes it ideal for Spring to weave expects into the target classes when the beans are being initialized and loaded into the IOC container. Let us understand AOP implementation in more detail. There are two distinct fundamental concerns to tackle while implementing an AOP functionality. First one is the actual implementation of the functionality. Here in this case, it is the logging implementation. And the second is the trigger mechanism of the functionality. Spring AOP supports method invocation join points, meaning AOP functionality can only be triggered if the corresponding method on a Spring Bean is called, as this animation shows. We will learn about both of these concerns in detail in this section, but first let us understand how to declare expects. Expect J refers to a style of declaring expects as regular Java classes annotated with annotations. The expect_j style was introduced by the expect_j project as a part of expect_j 5 release. Spring AOP allows us to declare expects in expect_j style. The expect_j annotations are only used to declare an expect. The AOP runtime is still pure Spring AOP. To declare expects using the expect_j style, we first need to enable Spring support for interpreting expect_j annotations. To enable expect_j support with Java configuration, add the enable expect_j autoproxy annotation as shown in this example. To enable expect_j support with XML-based configuration, use the expect_j autoproxy element as this example shows. Any bean defined in the Spring application context with a class that is annotated with expect annotation is automatically detected by Spring and used to configure Spring AOP. By default, any class annotated with expect annotation is not treated as bean within the Spring IOC container. We either need to manually declare them as beans using a bean annotated method or add any Spring stereotype annotations so they can be eligible for auto detection through component scanning, as this example shows. Expect annotated classes can have methods and fields the same way as any other class. They contain point cut, advice, or introduction declarations. Declaring a point cut. Point cuts determine join point of interest and thus enable us to control when advice runs. A point cut declaration has two parts: a signature comprising a name and any parameters, and a point cut expression that determines exactly which method executions we are interested in. A point cut signature is provided by a regular method definition, and the point cut expression is indicated by the point cut annotation. As shown in this example, the point cut expression that forms the value of the point cut annotation is a regular expect_j point cut expression. The within and execution keywords in the point cut annotation value represents point cut designators. Spring AOP only supports a subset of point cut designators supported by expect_j. The complete list of point cut designators supported by Spring are summarized in this table along with an example for each one of them. I am not going through each one of them one by one. If needed, take a pause and soak in the details. Next one is combining point cut expressions. You can combine point cut expressions by using the standard logical operators as the following example shows. Here I am using the AND operator. Declaring advice. Advice is associated with a point cut expression and runs before, after, or around a method execution matched by a point cut. The point cut expression may be specified as a simple reference to a named point cut or a point cut expression declared in place. Let us look at various types of advice one by one. Before advice. Before advice is executed before the method is executed, and they can't prevent the execution flow to continue to the target method. If before advice throws an exception, the execution flow is stopped and the exception is rethrown. You can declare before advice in an expect by using the before annotation. After returning advice. After returning advice runs if the target method returns successfully, that is, without throwing an exception. You can declare after returning advice in an expect by using the after returning annotation. Sometimes you need access to the actual value that was returned in the advice method. You can bind the return value to your advice method by using the returning attribute on the annotation as shown in this example. The name used in the returning attribute must correspond to the name of the parameter in the advice method. After returning advice has a void return type, meaning they can't change the final value returned to the caller. After throwing advice. After throwing advice runs when a matched method execution exits by throwing an exception. You can declare after throwing advice in an expect by using the after throwing annotation. You can bind the thrown exception in the advice by using the throwing attribute on the annotation as shown in this example. The advice is only executed if the exception of the specified type is actually thrown by the target method. In this case, the advice will only execute if the target method throws unsupported operation exception. After finally advice. After finally advice runs when a matched method execution exit. It does not matter whether an exception is thrown or not. The after finally advice is always executed. Think of it as a finally block in the track catch statement. It is typically used for releasing resources and other similar purposes. You can declare the after finally advice by using the after notation as shown in this example. There is no way to determine whether the method threw an exception or not. We also can't change the return value seen by the caller. Around advice. Around advice runs around a matched method execution. It has the opportunity to do the work both before and after the method runs and to determine when, how, and even if the method actually gets to run at all. You can declare the around advice by using the around annotation as shown in this example. The method should declare object as the return type and the first parameter of the method should be of type proceeding join point. Within the body of the advice method, you must invoke proceed on the proceeding join point in order for the underlying method to run. Invoking proceed without arguments will result in the caller's original arguments being supplied to the underlying method when it is invoked. For advanced use cases, there is an overloaded variant of the proceed method which accepts an array of arguments. The value in the array will be used as the arguments to the underlying method when it is invoked. The value returned by the around advice is the return value seen by the caller of the method. Note that proceed may be invoked once, many times, or not at all within the body of the around advice. All of them are illegal. Advice parameters. Access the current join point. Any advice method may declare as its first argument a parameter of type join point. Here in this case, all the three advices have declared the first parameter as join point. Note that around advice is required to declare the first parameter of type proceeding join point, which is a subclass of join point. The join point interface APIs allows us to access contextual information about the current join point, such as the target object being advised or the arguments passed to the target method. We did learn how to get access to return value or exception thrown, and now we have learned how to get access to method arguments and other contextual information about the target method using the join point API. However, the method arguments are returned as an object array and we manually have to typecast them to the desired type. Spring AOP allows us to write fully typed advice, meaning that you can declare the parameters you need in the advice signature rather than deal with object arrays all the time. This is a little more advanced topic and I'm skipping it intentionally in this video as it would result in information overload. Do let me know in the comment section if you want a video on this topic and I will try to pick this up in a separate video. Advice ordering. What happens when multiple pieces of advice all want to run at the same join point? The highest precedence advice runs first on the way in and runs last on the way out from a join point as shown in this animation. Unless otherwise specified, the precedence of the expects is not defined, meaning the order of execution of expects is undefined. You can specify the order of expects using the usual Spring way by either implementing the ordered interface or by using the order annotation as shown here. The lower the number, the higher the precedence for the expect. Introductions. Introduction as a term means the action of introducing something. Taking the same philosophy and applying it in the AOP domain, introduction advice as a concept allows us to introduce any additional functionality to the target object. Spring AOP lets you introduce new interface to any advice object. Consider the use case of tracking number of communications sent to the user. We can define a tracked interface which has a single API track. Implementations of the tracked interface must make sure that each time the track method is called, it will increment the communications count of that user by a value of 1. Next, we can have a before advice which is applied before the execution of the methods in the communicator interface. We can use our tracked API within this before advice to fulfill our requirement. To declare introduction advice, we need to declare two distinct aspects. First one is to declare target classes which is being advised. This is achieved by using the declare parents annotation as shown in this example. It means that matching types have a new parent. The value attribute specifies the point cut expression. In this case, all beans defined in the service package are selected. The new parent interface to be implemented is determined by the type of the annotated field, and default implementation specifies the default implementation to use for the introduced interface. Next, we need to invoke the newly introduced functionality. We can plug any type of advice we have learned in this section. Here in this example, I am plugging in a before advice which is executed before the execution of any method in the communicator interface. In the advice body, I am invoking the track method which does the work of actually keeping a track of number of communications per user. If you have understood the concept of proxy objects fairly well, you can imagine that Spring will create a proxy object for each of the target classes, and the type of the proxy object would be the new parent interface that was introduced. AOP use cases. I am highlighting some common AOP use cases below. Take a pause to go through this list. I am not going through them one by one. In this video, we have learned about Spring AOP, and the examples were taught using expect annotation style with all the expects defined in Java. Practically, this should be sufficient for almost all use cases. However, there is another Java AOP framework which is specifically designed for expect-oriented programming and provides some complex AOP functionality which is not supported by Spring AOP. Detailed understanding of expect framework is out of scope of this video, but I have summarized the key differences in this table. This brings me to the end of this video. If you have any doubts regarding this video or Spring Core lecture series in general, kindly do comment in the comment section. As always, thanks for watching. Do subscribe to the channel and share the content as much as possible. I will see you in the next one.